This is the problem we worked on today in class. And I said that the answer was false, but then as I thought about it, I wasn't sure because I needed to explore what it looked like for the power set of, or for A to be a proper subset of the power set of B. So we're going to explore that now, and in thinking more about it, I believe the answer is actually true. So let's see. All right, so in order for A to be a proper subset of the power set of B, that means that B, or the power set of B, has to have at least one additional element more than what A has. It told us that A has two elements, so let's just do an example. Let's say A was a set that contained the elements A and B. Well, if A is a proper subset of the power set of B, that means that all of the elements inside of A have to be in the power set of B. Let's say that again. Remember, in order for something to be a subset, every element in A has to be an element in the power set of B. Well, remember, the elements in a power set are all sets themselves. So that means that the elements in A has to be some set. I don't know what's in there. Let's say maybe the letter C is in there. And the element B has to be a set as well. And I know that because the power set is a set that contains all of the subsets of B. So now I know that my set A now looks like this. So if these sets are elements in the power set of B, then that means that B contains at least the elements C and D in them. It may have more. As a matter of fact, well, it may have more elements in it, but I know it at least has the elements C and D in it. So for now, let's assume that these are the only two elements in B. What would the power set of B look like if that's the case? So the power set of B is going to contain the empty set, is going to contain the set that contains C, the set that contains D, and then it's going to contain B itself. That's the set itself. And that's consistent because I have two elements in B. 2 to the second power gives me 4. So I know that my power set is going to have 4 elements in it. And as you can see, it's consistent with the fact that it has the elements in set A in it. This is the smallest that the power set of B can be, because we know that it has to have at least these 2 elements in it, which means that the power set itself has to have 4 elements in it. So since I know that the power set of B, it says, is a proper subset of C, and I know that this, the power set of B, the number of elements in it, has to be at least 4, then it must be true that, remember, C has at least one element in it more than the power set of B. So that means that the absolute value of C, or not the absolute value, forgive me, that means that the cardinal number of C has to be at least 5. So when it says that the cardinal number of C can be 5, but it cannot be 4, that actually is a true statement. This is not a proof, it's just kind of a reasoning. Perhaps I'll write it out for you in a more formal way. I can do that as we're practicing how to write our explanations out. So I'll make sure to go on and write this out in a more formal way for you. But I wanted to go on and show you and correct myself when I said that the answer looked like it was false. It's actually the case that the answer is true.